Weather is defined by short-term atmospheric conditions: temperature, rain and snow, winds, etc. Climate is the average of weather conditions for a particular location over decades or longer. To put it simply, climate is what you expect, and weather is what you get. If what you get no longer matches what you expect, then we might be witnessing climate change. In this video, I will review some of the major climatic changes we are currently experiencing and those we expect in the future. For millions of years, humans and their hominid ancestors endured drastic climate changes, including glacial and interglacial periods. However, during the past 10,000 years, the Holocene, Earth has enjoyed exceptional climate stability, which enabled the rise of human civilizations, from early agriculture to modern societies. This stability allowed our population to grow from a few 100,000 to over 7 billion. Over the last century, climate started to change. This hockey stick graph illustrates the sharp rise in temperatures in the late 20th century. This increase mirrors the rise in CO2 levels, as shown by the Keeling curve from the previous video. So, what's all the fuss about? Considering daily temperature changes of 10 degrees Celsius or more and seasonal differences of up to 50 degrees Celsius, a 1.5 degrees Celsius or even 2 degrees Celsius temperature rise over a century might not seem that alarming. However, this is a dangerous misconception wrongly touted by climate change deniers. As you see on this heat map, global warming is not uniform. Polar regions are heating at up to 4 times the global average due to the ice-albedo positive feedback loop we discussed in the previous video. To remind you, ice reflects more heat than ice-free oceans and land. The warmer it gets, the more ice stores, and the resulting ice-free surface absorbs more heat, leading to further heating and the loss of even more ice. Temperatures on land have generally increased more than sea surface temperatures. As most of the continents are in the northern hemisphere, temperatures there in Europe, Asia, and North America have increased above average. Sea level rise is one of the most alarming and well-publicized effects of climate change. Sea levels rise due to 2 reasons. The first is the melting of terrestrial glaciers, particularly the ice sheets that cover Greenland and Antarctica. The second is thermal expansion. The hotter the water in the ocean gets, the more space it takes up, leading to a rise in its level. These 2 effects have so far contributed roughly equally to the rise in sea level, which amounts to about 20 centimeters over the last century. It is hard to predict if and when big terrestrial glaciers will collapse. Currently, all eyes are on the West Antarctic ice sheet, colloquially termed the Doomsday Glacier. Its possible imminent collapse could trigger a sea level rise of up to 1 meter by 2100. Unlike extreme weather events, it is not possible to view sea level rise with the naked eye, but it is nevertheless one of the major threats of climate change. Indeed, a recent study showed that 230 million people live below 1 meter from the current high tide lines. I am boarding the commuter ferry that connects Lower Manhattan with Staten Island. This free ferry is highly popular with tourists as it passes, as you can see here, close to the Statue of Liberty. I took this 25-minute trip as it offers an excellent vantage point to appreciate and show you how close the city home to the famous financial district and the Wall Street Stock Exchange is to sea level. These skyscrapers look as if they virtually grow out of the sea. In 2012, Hurricane Sandy caused immense damage, disruptions, and loss of life by flooding much of this area and other parts of New York City. Melting polar ice introduces fresh water into the oceans, affecting ocean currents. These currents serve as Earth's climate regulators by transferring heat from lower latitudes to higher ones. Weakening currents, like the Atlantic Meridional Overturning Circulation AMOCs, which comprises the Gulf Stream, will lead to colder winters in Europe, intensified storms on the US East Coast, and disrupted monsoon patterns in Africa and South Asia. Such changes endanger the water and food security of billions. Extreme weather events have frequently made headlines in recent years, and most of us have experienced them firsthand. One of the major reasons that temperature increases lead to extreme weather events is that every 1 degree Celsius rise in air temperature increases its water vapor capacity by 7%. Over the sea, this hot air gets supercharged with water, fueling intense rainfall from storms, hurricanes, and cyclones. As precipitation increases, it often exceeds natural and built drainage capacities, leading to floods. This is true both inland and along coasts. Rising sea levels further exacerbate coastal flooding, threatening cities like New York, Mumbai, and Beijing. The flip side of increased temperatures over land are droughts. Warmer temperatures lead to higher evaporation rates from soil, lakes, and rivers, reducing water availability and drying out the land faster. The hotter the air, the higher its capacity to absorb and retain moisture. Extreme weather events used to be rare outliers of the normal climate. Once such events become frequent, they can no longer be considered outliers, but rather the new norm of a changed climate. Climate change damages the environment and adversely affects societies by leading to food and water insecurity. It is claimed, for example, that the civil war in Syria was initiated by climate change. The ripple effects of this war, which claimed 500,000 lives and left the country in ruins, are felt far away as millions of refugees influence Europe's politics. Public health risks are also rising, with the spread of diseases like malaria and dengue and worsening air quality impacting vulnerable populations, particularly in developing nations. As humanity entered the stable Holocene, it consisted of small and resilient groups of hunter-gatherers. The vastly different humanity exiting the stability of the Holocene will struggle to accommodate the dramatic climate changes it might experience. We must do everything possible both to minimize climate change and to prepare humanity for the inevitable changes ahead.